Hi, I'm Andras Kavlets, and I'm the owner of Checkpoint VFX here in Burlingame, California. Checkpoint VFX is a VFX studio specialized in look development and visual effects for TV series and film, and I'm also the CG supervisor. Now in this webinar, I want to talk about how I use Modo here at Checkpoint VFX. And then I also have prepared a sizzle reel, which is a shorter, more compressed version of the Checkpoint VFX reel. And then I will be also showing a short movie that was entirely done in Modo. And now, like I said, I want to talk a little bit about my career. So I started creating CGI back in 1989, and the computer back then I used was the Atari 520 ST. Now this computer had a very limited hardware, and it had only a resolution of 320 by 200 pixels, and in this resolution I could use 16 colors out of 512, so that's not a lot. And all the graphics were done by hand, so all the pixels were set by hand. And to do that, I used the mouse, and back then I didn't have anything like a Wacom tablet. And the two applications I used back then was Neochrome and Deluxe Paint ST. Both were very similar, and both had similar tools, and both allowed me to choose these 16 colors out of 512. And then they had tools such as a pencil tool to set the pixels, then copy paste, fill bucket, and some basic animation tools. So both software were very limited, but the hardware was limited too. And now these here are two images that I created back in 1994. So that was 27 years ago, and both images were done by hand. So I set all the pixels by hand, and I also did the anti-aliasing by hand. Now the third image here is a screenshot out of a shoot 'em up game that I was working back then, and again the graphics was done by hand. And so after the Atari 520 ST, I bought a Atari Falcon, and this computer had a far better hardware, and it had a resolution of 640 by 480 pixels, and but it could display 256 colors, and it even had a true color mode, and that was a huge improvement from the Atari 520 ST. Now after the Falcon, I moved to the PC, and again I was using Deluxe Paint for the PC, and again in Deluxe Paint I was able to use 256 colors, which again was a big jump from coming from the Atari ST with only 16 colors. And so this here is a timeline of my career. So like I said, I started off doing pixel graphics in 1989. Then around 1993, that's when I worked on my first commercial computer games, and I worked on a Atari Jaguar game and also a pinball game for the PC. And I stayed for quite some time in games, and I worked at companies like Sunflowers Entertainment, Electronic Arts in the UK, LucasArts in San Francisco, and also NCSoft. And I held different positions in the games industry. So I started off as a 2D artist, then I became a 3D artist, then I did 3D characters, 3D animation, logo animations, and worked on cinematics. And then I also worked on real-time particle effects for the next generation consoles, such as the Xbox 360 and PlayStation 3 and 4. And around 2010, that's actually when I moved from games to TV and film. And again, I held different positions. Started off as a CG generalist, doing modeling and texturing, and then later on I became a CG supervisor, and I worked on different TV series and films. And then in 2016, that was the year when I opened Checkpoint VFX here in Burlingame, California. And like I said, I started off as a 2D artist, and then around 1996 that's when I saw Lightwave 3D on a PC, and it just got ported from the Amiga to the PC, and so that was also the time when I switched over from being a 2D artist to become a 3D artist. And in 2005, that was the year when I saw the first time Modo 201, and it was very similar to Lightwave, but it had a modern interface, and it had I saw a big potential in Modo, and so I'm still using Modo here in 2016 and currently using Modo 15. And now this one here, this slide shows just a couple of projects that I worked on, very early on projects in my career, games that I worked on back in 99, and then TV series and a couple of TV series, like I said, and film projects. And I've worked on far more projects, but you can look me up on IMDb or just visit the Checkpoint VFX website to read more about the projects that I worked on. Now, I would say I want to show the sizzle reel, which again, like I mentioned, is a shorter, more compressed version of the Checkpoint VFX reel. It shows quite a wide range of different projects and different styles, and Modo was used in most of these projects. So this was the sizzle reel, and now I'm going to show the short movie I was talking about, which was entirely done in Modo. So this was the short, and now I want to talk a little bit about how the spaceship was actually modeled in Modo. Now the spaceship itself comes with like two different challenges. One of the challenges is that it has a very organic shape, and then the other challenge is that it has very highly reflective materials, which can easily show any modeling imperfections like small bumps. And now during look development phase, I'd like to stay flexible as long as possible. And with flexible, I mean I want to be able to do a lot of iterations and a lot of changes very quickly and easily. And now this ship was not modeled the traditional way of like cutting in all the details by hand, but rather I used Mesh Fusion for that. And Mesh Fusion is usually used for smaller objects and also a lot of product visualizations you have probably seen. And but it can be also used on so Mesh Fusion can be also used on larger objects too, of course. And now Mesh Fusion itself is a real-time live Boolean tool in Modo, which allows you to move around your trim objects, and so you can change your trim objects. You can very easily change basically the details that you want to cut into a surface. And I'm gonna jump into Modo and I'm gonna show the final ship, and then I'm also gonna show how I've modeled in some of the details using Mesh Fusion. Okay, so this is the spaceship loaded up in Modo 15, and that's the final version of the ship. And it's a little bit hard to see all the detail. And I'm just gonna turn on matcaps. Matcaps are just a material override only with a viewport. If I turn this one on, we can see a little bit better the detail. And then actually Modo comes with the library of matcap materials, so you can just switch between these materials. So you have like highly reflective materials, and I'm just gonna go down here to this one here, which is called Blue Pearl, which looks more green than blue, but this one here works quite nicely. So again, this is the final ship, and as you can see, it has a lot of detail here, a lot of detail that has been cut in using Mesh Fusion. And yeah, but you can see that the model is very clean. I don't see any big surface imperfections on it. And now I'm just gonna go in and I'm just gonna switch over to another scene, and I'm gonna show the process of how I'm cutting in all these details. So before I'm going to talk about Mesh Fusion, I just want to point out that in Modo you can have multiple scenes open, and then you can also drag and drop a copy paste between these scenes. You can copy paste items, lights, cameras, which is really handy. So there's no need to export and import objects from one scene into another scene. You can just drag and drop them. And okay, so let's have a look at this other scene here, which has the basic hull object, and it's a very simple object, as you can see. It's not much to it, and I'm just going to convert this into a new Mesh Fusion item, which looks like this, very similar to the base object. And then I'm just going to turn on these trim objects here, and just let's focus on just the first one here, which, as you can see, it's a very simple cylinder shape and some simple rectangles cutting, intersecting with the hull. And the next thing is I'm going to turn this object into a subtractive trim object. That means it will cut in and trim away certain parts of the main hull, and this is the result. And what I can do is I can take the cylinder, for example, move it up a little bit so it doesn't intersect with the hull, and then the result will be that it doesn't contribute to the cut here. And let's just undo this, and then let's just move this down here just to demonstrate. Now you can have a total different look, and then as you can see, the end result of the mesh fusion, or the Boolean operation, looks really nice. I don't see any really big problems here. And let's just undo this. So we go back to the original trim object, and let's focus on the next object here, which is again just a piece here in the middle, and then two smaller cubes also cutting into the hull. I'm just going to convert these also into a subtractive trim. And now let's have a look at this result here. Again, it added these lines here, and then also these rectangle shapes here. And again, it's really clean. And now let's have a look at this one here. These are here the air intakes, and these shapes are quite complex, and I'm just gonna again add them as a subtractive trim. And let's have a look at the result. Again, really clean, and you can imagine that cutting this shape into the hull the traditional way would take quite some time. And the good thing about mesh fusion is, of course, we can just go into these air intakes and move these polygons and reposition them somewhere else. So again, this demonstrates how flexible mesh fusion is, especially for the look development phase. Now let's just undo that again. Okay. Let's have a look at the last object here, which is just a larger piece here. And again, it's going to be a subtractive trim. And this is the final result. So it added really long cut lines here across the entire hull. And again, really clean mesh. I don't see any kinks, any bumps, any errors. And so now you can, I'm just going to jump back into the final ship here, and you can convert the mesh fusion item into a polygonal object, and then if you want you can retopologize or just use this converted polygonal object and just start texturing it, shading it, and then rendering it. And this was actually also how the spaceship was done for this short. And so it was a really straightforward process. And this also concludes my talk about mesh fusion and the spaceship. The next shot I want to talk about is this one here, and that's the underground shot when the staff is being pushed into the soil, and then we see the gravel basically being pushed away, and then we also see the sprouting. Now, before I go into Modo again and show you guys the setup of the gravel, I'm just gonna play this shot again. This shot was initially planned as a practical shot, and this is just a vase filled with gravel, and I'm actually pushing in a metal staff just to observe how much movement we see on the gravel. And now I'm just pulling out the staff just again to observe how much movement we see. Now this shot, like I said, was initially planned as a practical shot, but then it was turned into a fully CG shot, and I will be showing you the setup of the shot. So this is the gravel shot loaded up in Modo 15. And I just want to point out that we have 2,513 individual gravel stones that were actually simulated in this shot. Now, I'm just going to show you my setup. So basically, there is this simple object here, which is a collision object for the stones. Now, what I did is I placed the stones initially up here, and then I applied dynamics to these gravel stones. And then this object here, like I said, has a collision applied to it. So when gravity pulls down these gravel stones, they will collide against this collision object, against the ramp, and then they will roll down, collide against each other, and also collect in this lower area here. And since they're colliding against each other, they won't intersect each other, which was also very important for the second dynamic simulation. And now let's just turn this object off again, and I will just go back into my matcap material. I'm just gonna turn off selection and just turn off the wireframe. I'm just gonna go back into the camera. So what's very important is that there's enough stones, enough gravel stones to fill up that area that the camera sees. And then, of course, like I said, it's very important that they're not intersecting each other. So, and that's also important for the second dynamic animation. And so what's going to happen next is this staff here is also a dynamic animated collision object. And I'm just animating down the staff going through the gravel, and then will collide with the gravel, and then it will push away the gravel stones. And then also the gravel stones are colliding against each other. So now for this simulation, only these stones around the staff were simulated. So none of these stones out here, because they're not moving. And so this is the result here, just quite convincing. So when I go into my camera, I can see it here. And there's a lot of motion going on, like in the reference video that I shot. And yeah, so this was how this shot was actually realized completely in Modo. The last shot that I want to talk about is this one here. That's the landing shot. And this shot is quite complex because it has all the environment in it, it has the ship in it, has particle effects and volumetric effects. Everything is animating, so the ship is landing, the camera is moving, so everything had to be timed rather well. And before I go into Modo again, I'm just going to play this shot again. So I have opened up this shot in Modo 15, and when I scrub the timeline, you see the ship landing. And what I've done is also I've rotated and animated out these side panels so that they actually act as legs for the spaceship to land on. And the front of the spaceship also has two ramps which are rotating down, and then they also colliding with the floor. So this ramp is actually acting as a third leg for the spaceship. And then the last thing that is animated on the ship are these side panels here. And so they're animating out and open up. So that's about for the animation of the spaceship. So when I zoom out, you see that the environment is hidden. So let me just turn the environment on. And the environment is actually just made out of 4 simple planes. And simple, I mean they're really simple. So when I turn on the wireframe, you can see that these planes are just tessellated planes. And all the detail for the environment is actually happening during render time through 2D displacement maps. Now, I can actually also preview these displacement maps in the viewport. But I'm just going to select all 4 planes. So I'm just going to set the subdivision level to 8. And I'm just going to reinitialize the viewport. take a second. Here we go. So that's the preview of the 2D displacement maps in the viewport. And again, this is just a preview, so you will see a lot more detail in the final rendered image. Now, what I've also added, I've added the landscape behind the camera and left and right to the spaceship. So we have a panoramic environment for the spaceship, because the spaceship has a very reflective material, so you want to see the environment reflecting in the spaceship. So that's very important. Now, when I zoom in, there are two other things that I want to show. One of them is these replicators. These replicators are actually going to replicate small gravel around the spaceship and close by the camera. And these are gravels in all different shapes and sizes and orientations. So that gives a lot of detail. And you will see the detail here in the camera viewport. So this detail is rather important for the close-up shot here for the ground. And so these gravels are not important for the background here because you will never see them. They're going to be so tiny. And this is also going to help with the render time. Now, let me just turn off these replicators again. I'm just going to go into my perspective viewport, and I'm just going to turn on these high detail stones that I placed around the spaceship. Now let's just jump back into the camera, and you can see that these stones are actually contributing quite a lot to the design of the environment to make the environment more interesting. And I've also placed these stones between the camera and the spaceship, so they are occluding a little bit of the spaceship. So we get a little bit of parallaxing also going on, which is also very important. Now, what's also important is that these stones are arranged in a way that they are also being recognized in the other shots after this shot. So you always know where you are, which means you can always recognize the environment when the pilot is walking around. So, well, that concludes my talk about this shot. Before I'm going to wrap up this webinar, I just want to point out a few plugins that I used for this short. One is ACS2 by Lucas Pacera, which is an auto character setup plugin for Modo. It ships with a biped character rig, which is very robust, fast, and also customizable. And there's also ACS3 on its way, which allows for quadruped rigs. I also highly recommend this plugin. The other plugin that I use is Tropism, and that's a procedural growth plugin inside of Modo, and you can generate trees with it or animate veins. And then I use this plugin for actually the sprouting shots. Now then there's Quad Spinner Gaia, which is an external tool to generate landscapes. And it's a procedural but also artist-driven landscape generator. And then once you are happy with your landscape, you can just export it as a 2D displacement map and then just render it in Modo. So I hope you liked this webinar, and I also hope that I could share some valuable information. And I would say see you in the Q&As.